To quickly introduce myself, my name is Arnaud Soullié. I work at Wavestone as a senior manager, and I've been working on ICS, which stands for Industrial Control Systems, cybersecurity for quite a long time. My first job on this topic was, I think, in 2012, so right after Stuxnet. That's what really got things started. And since then, I was part of the pen testing team. Now I do a little bit less pen tests. I still do security assessment and a little bit of consulting, I would say, but 100% on ICS cybersecurity. So maybe to give you a small reminder on ICS and for you to enjoy the rest of the presentation a little bit better. I have this one slide. I'm going to spend like a few minutes on it just so you have a basic understanding of industrial control systems. And in the rest of the presentation, I'm going to say ICS like 3, 4, 5 times a minute. So don't be afraid. That's okay. I'm used to it, and I hope you will get used to it too. So on the right side of the slide, you have what I call the physical world. So let's say you have a big factory, you're producing something. I've seen quite a lot of things from nuclear enrichment to frozen fish sticks. So a large variety of things with different cybersecurity stakes. But let's say on the right side, you have big machinery in a factory, in a plant. So you have reactors, you have big, large motors, pumps, as well as electrovalves and a lot of things. You want to automate the way those devices works. That's what ICS is used for. And so you have two things, sensors and actuators. So the sensors, like this looks like a sensor. They give you information about the physical world. So let's say you have a temperature sensor. It will transform the temperature into an electrical signal. The actuator will do the opposite. It receives an electrical signal and it will transform that into a movement. So like, for example, here you have an electrovalve. The idea is that if it receives 0 volt, it will allow the flow through the pipe. And if it receives 24 volts, it will close the valve and then the flow will stop. So in order to manage those devices, you have very specific hardware, something that is called PLC. I'm not getting into all the details. That stands for Programmable Logic Controllers. Basically, it's a small embedded computer that has electrical inputs and outputs. So you can directly wire some sensors and actuators to the PLC. The PLC has a very, very small memory, is able to do a little bit of automation, like saying, okay, I will keep the valve open until the tank that I'm trying to fill has reached a certain level. That's a basic process control. So the PLC is in charge of a very small part of an industrial process, okay? Most of the time, those PLC will be wired using Ethernet. And as I mentioned, they will control a small part of the process. But if you want to be efficient, if you want to earn a lot of money, you want to automate the whole factory. So you need an additional layer. And this is where you have your SCADA or your DCS. Well, you have your supervision network. Here you have standard hardware, so most of the time Windows servers, Windows workstations, and they have specific software that is able to query data from the PLC on a regular basis. So let's say you have your SCADA screen, it displays the state of the industrial process in real time, and you can also interact with it. You click on a button, it sends a command that will send a request to the PLC, and the PLC will send the electrical signal to the actuator to perform some kind of action. Okay, so this is historically the ICS. Of course, for most of my clients, they also, to some extent, have a connection to a corporate network. And I emphasize that because they need to be some data exchange between the SCADA and the corporate network. For example, you may want people in the SCADA network to access some documentation that is stored on the corporate network, and you may want the corporate network to get some data about how much you have produced, etc., etc. And of course, on the left side for you, you have the WAN, you have internet, etc. Okay, so basically, this is an industrial control systems. Now we will talk about a little bit about the protocols. So historically, for the SCADA to discuss with the PLC, there were some dedicated protocols. You may have heard of Modbus, Profinet, Ethernet IP, CIP. So by the way, Ethernet IP has nothing to do with Ethernet or IP. I mean, it's a protocol at the application layer that's called Ethernet IP. So that's a little bit confusing. And those protocols, they, most of the time, all the time, they have almost no security at all. That means no authentication, no encryption, and they are replayable. So if you are able to capture the traffic, you can just replay the traffic and you will be able to perform the same action. Which, of course, is not great from a security perspective, but that's the way it is. And by the way, those protocols are still in use today in most factories, okay? So, as mentioned, here you want to exchange some data, but maybe you do not want to use Modbus, you know, from the corporate network to access the data from the PLC. So that's why they created in the 90s, I think, something called OPC. There's a foundation that defines some specification for industrial protocols. And the first version from the 90s was based, heavily based on Microsoft technologies like DCOM. And so that was not really good from a security perspective because it doesn't play nice with firewalls. You have dynamic ports that are negotiated, I think. And of course, it's not very interoperable because it's very limited to the Microsoft world. So it was not really good, but still it was deployed to some of our clients to exchange data. But what I will talk about today is a new protocol. It's called OPC UA. Before going into that, the basic situation I'm describing is the following. You have what's called an OPC gateway, which means from a security perspective, you do not want the corporate IT to directly connect to the PLC in the heart of your industrial control systems. So most of the time you install an OPC gateway. This OPC gateway will use Modbus, Profinet, and all the specific legacy ICS protocol to gather some data from the PLCs. And then you will use OPC protocol to gather the gateway from the corporate network. Okay? So far, so good? If you have some question, you can ask. If you do not do that, I will talk a lot and quite fast. Okay? So, the topic of today, OPC UA. I'm quite excited to talk about OPC UA because really it's a game changer. It's a brand new protocol created in 2006. It's cross-platform. It's available for free. That means you can easily get the specification from the foundation. And something that is quite unusual in ICS, it provides security features, which is really, really great. So, OPC UA, you can use that on several transport layers. To be honest, I've only seen TCP used, but there's a version that works on top of HTTP. So if you already have reverse proxies and stuff like that to do a little bit of security, you can use that. And it also works over MQTT. I've never seen that, but I know that it's possible. A few new things that were introduced with OPC UA. There's something called PubSub, so you can actually subscribe to data change. So instead of polling the PLCs every 100, 200 milliseconds to get new data, you can simply wait for the data to be pushed back to you, which is nice. Another big advantage that's not really cybersecurity related is that there's some data models as part of OPC UA which allow you to precisely describe not only the value of the data, but the context of the data and the type of the data, which means, I don't know if you work in the oil and gas industry, you will have some dedicated type of model that are already, I would say, fitted to your industry. So, for example, I don't know if you have a refinery, you will have all the different data blocks that are easily, that you can easily use. It uses namespaces and nodes. I will come back to that later with a demonstration. And, well, it's a very complex protocol. I talk about Modbus. Modbus, it's 70 pages of specification, really easy to understand. OPC UA, it's thousands of pages, so it's really hard to understand. And as I will show you later, my colleagues try to develop a tool to interact with OPC UA servers, and just getting a value for a specific node is a nightmare because you first need to find out where the type of the data is stored. It's in a specific node, and then once you know the node, you can query the data. So it's really, it's a nightmare in terms of complexity. So I said that OPC UA provides security features. So yes, you can have both signature and encryption. So the first thing that you define when you create an OPC UA server is the security mode. It can be none, which means no security at all. It can be sign or sign and encrypt. there's a big difference, and people in ICS cybersecurity, they like to be able to sign things without encrypting them. Why? Because a lot of people are selling products and solutions to do what they call passive network monitoring, so basically an IDS, but specific to industrial control systems. And so for monitoring purposes, it's nice to know that when you send an order, the request is signed, so an attacker on the network is not able to send a valid request. However, since most of the time in ICS the data is not confidential, I mean, nobody will be able to win some money by knowing that the value of the valve is 0 or 1. Doesn't make sense. So it's nice to be able to sign and not to encrypt. And in addition to that, you have the security policy, which defines what type of algorithm you will use for either signing or encrypting or both. Okay? So really a huge improvement. In addition to that, you can also have authentication and authorization using either certificates or password logging and passwords. So really it's kind of a secure protocol on paper. And again, huge improvement over legacy ICS protocols. However, the technical implementation are not flawless. I've performed a few pen tests or security assessments where there were OPC UA servers available, and quite frankly, it was never configured as it should have been, okay? So, just to give you an overview of how it works, you send an hello sequence, then you open the secured channel by using the certificates, and then you open the session by authenticating if authentication is enabled. So, I want to talk today about OPC UA Scan. It's a tool that my colleagues developed for OPC UA discovery and, let's say, information gathering. So I'm presenting today, but I want to mention the name of the people that did the development. So it was an intern working at Wavestone. It's called Simon Eudeline, and it was managed by one of my colleagues, Paul Isnardon. I was the client, so mostly I said, I want a tool that does that, and they did it. And after that, I did some, because I felt bad, you know, I thought I'm presenting on a topic and the code was done by somebody else. That's not very ethical. So I also did some commits to the code just to be sure to say, okay, I'm a part contributor to the code. And now I'm going to switch to some of the VMs to show you what it looks like. So let me see if everything is running as expected. So,
and what version of OPC UA is because first version, I don't think it was very secure, and I have seen some kind of communication through HTTP.
Yes.
And you could just grab your Wireshark or whatever you want, or another you would do passive scan, and you could just grab the message, and it was basically just a Modbus embedded in HTTP. And there is many versions, and the first one was not secure at all, I guess. Not I guess, I'm sure about it. So you are talking about the last version?
I'm not very familiar with the different versions. As I mentioned, I've seen a lot of implementation where the configuration was not top-notch, that's for sure. But I'm a little bit surprised that the way it works, you shouldn't see Modbus requests inside of OPC UA. I'm going to show you what it looks like on my setup.
But on TCP, I have some
Yes, it will be on TCP. On HTTP, quite frankly, I've never encountered that. So for the demonstration, just to explain a little bit, I'm using a software that's called Kepware. Kepware is an OPC UA gateway. It looks something like that. It's not really interesting, that part, but just to show you, that's the name of the server, and you have a version that's free to run for 2 hours or something like that. And so basically, that's a gateway. So here I define a channel, and in my channel I define my devices. So those will be the PLCs. And for each of them, I define what I call a tag. A tag is simply a variable, and for each tag, you map it to a device and to a memory address. So for example, here, something that's called, let's say this one, that I called coil, it's mapped to the new PLC device at the address 2. Okay, so that's how it works. And now I'm going to connect to this OPC UA gateway to try to gather some information. Okay, so that's the first step. I just do the hello scan. So remember, that's the first step of the connection. So it discovers the OPC UA server. Here, I already knew the IP and the port. I'm not going to go into the details of, okay. I'm not going to go into all the details. This is not a very standard port, but in my experience, each implementation uses a different port, so I don't think that it's not like RDP where everything runs on the same port. So you can gather a few information like the type of server. Here I know the product, etc., etc. And here I discovered two URLs because on the same machine I actually have two different OPC UA servers running, or at least two endpoints. Okay. So next step, I want to gather some first information. So I will use the server config directive from the tool. So I'm very lazy, as you can see. But I'm well prepared because I did a lot of requests. Okay. So now, what does it say? It says that there are two endpoints. The first one has only one security mode, none, so you do not need a certificate to establish the connection. And then you can either connect anonymously or using a username. The other endpoint...
When you mean the certificate, the client certificate?
Yes. Yes, it's heavily based on certificates. X509 certificates. The second one is configured to use sign and encrypt with this security policy. So even if this one is called anonymous, you will not be able to connect without a certificate because you won't be able to comply with the security mode. Okay, and so here basically what the tool tells us that we are able to connect as anonymous for one of the endpoints. That's the whole idea. That's something that we would use. The idea is to use that in security assessment, you know.
If you go to the slide before.
This one?
No, the next one. Next. The fact that on the line where the tool outputs information about port 49321, and like on the left side it puts 320 is normal, and it's talking about a different issue. On the left hand side.
Yes, because I'm using this port to connect to OPC UA, but it tells me that there are two different endpoints on the same server. So that's an information I get back. So I could find that by doing a port scan, but if I do a port scan and I just get the first one, I will still be able to identify the second one using
So you know about other instances on the same server?
Yes. And everything I'm saying today is based on the test that I've done on Kepware. Kepware is, I'm not going to say the leader, but it's one big player. But I've noticed that it doesn't behave exactly the same way for all the software. So even if it's a standard, quite frankly, not everything works as expected when you use different type of OPC UA servers. Okay, so then what we implemented was a feature to identify the nodes to which we can write to. Let's say you're in a pen test, you can read some data, but you want to see what you can actually do on the process. So if you do the NW switch, let's see here, we should be able to see the nodes that we can write to. So basically it iterates on all the nodes and subnodes to try to find the ones we can write to.
Does it try to write something or
no? No, it's just querying some properties. Yeah. So at the moment we are not trying to mess with the industrial process so far. So we just identify, and here we can see that we have current read and current write. Okay. So apparently we can write to 11 different nodes. However, that's not really true. And that's where the standard thing is a bit weird for me. So let me continue on the slide. Yes, so the next feature would be to read some data. So I'm just going to do that. And this will allow me to show you what I mean with namespaces and nodes. Okay, so here I'm connecting to the endpoint that doesn't require a password. And here I have the list of nodes. So that's the root of the server. So I will go to the node that's called I equals 85. So I think it's something like that, if I remember correctly. And here I can just browse what's available on the server. As you can see, here there are some errors because my username, Anonymous, is not able to read everything, okay? But I want to continue and browse on this one. It's hard for me to explain really why, but those things are information about how the system is configured. It's not really interesting to me. The only thing that's interesting to me is this one because it's the devices that I want to read from, okay? So I'm just going to copy that. Okay, so if I go here, I see device 1, device 2, and UPLC. And if you remember correctly, those are the devices that, I know it's a bit small, sorry, that I configured here in the OPC UA server. So let's go back here. We have some devices, and let's say now I go to new PLC. That's the last one. Okay, and I can see coil 1 and coil 2. And let's say I go to coil. You can see that there's the address. Here I can read, write, there's a description, etc., etc. So basically the protocol allows you to get some data and browse the data, write some data, etc. Okay? What I wanted to show you, and I hope this will work, let me go back one step, go to device 1. No, maybe device 2. Yes, this one. So if I continue browsing, and I try to read some information here. Okay, it doesn't work because it's written read write. Maybe it's not the right information. Okay, so for example, as you can see, if I go to a specific tag and I read the properties, here it tells me that the access is read-only. However, this one, you probably don't remember it, but was mentioned in the list of the tags that I can write to. What does it mean? It means that the way Kepware, the software that I'm using, is using authorization doesn't really comply with the standard. So my script says it's read-write, but when I want to write, it's not going to work because there's a specific property called client access that is not part of the standard that prevents me from writing to it. Okay, that's what I wanted to mention. Then let me go back here.
It depends on what? Like it depends on the vendor or something like that. Like for example,
each vendor is free to implement the standard the way it wants, and Kepware does it in a weird way because if I use the standard feature to get the access right, it's not the same as the real access right. And I think it's because OPC UA is still a moving protocol. There's a lot of different chapters in the specification, and I'm not sure authorization is fully published yet. So, you know, it's like, it's a bit weird.
Can you have the same but inverted? It's written readable only, read-only, and in fact it's writable?
I don't think so. I tried to tweak the configuration a little bit. I do not think that you could have no, I don't think so. You can have a false positive, but I'm not sure you can have a false negative.
Like all OPC UA tools at least comply 100% with the specification, and then maybe add other flags of the specific things like here.
yes.
I cannot answer yes to a question that says, do all the vendors do something? I can only say that I've seen that there are some things that are not really, in my opinion, normal. But
my question was more like, does the industry, ICS-wise, need to use a tool that is 100% compliant with the specification or not? Or is there any constraint about that?
The way it works in ICS, there's a lot of what we call vendor lock-in. So people that have paid dozens of millions of euros to Schneider Electric to have automation, they will keep Schneider Electric around for 30 to 40 years. Okay, so at some point, interoperability is something still quite new in ICS, because before you just bought the full package from one vendor, and then the vendor does what he wants because the PLC will only talk to the SCADA from the same vendor, etc. So now it's changing a little bit, but you will still see some weird things. Okay, I'm not going to go into too much details. So here you have some commands on how to use authentication, username and password. Yes, the last thing I want to mention is this, and this is maybe the only new thing as part of the presentation. It's something I discovered during a security assessment. I didn't know about this feature. There's something that's called dynamic tags. And let me explain what that is. As you can see here, the way I described it, when you create your OPC UA server, you have to manually declare all the PLCs and manually declare all the tags. In a real ICS environment, that would be thousands of tags. A large ICS environment has probably 10, 15 thousands of different tags. So that's a lot of work. So maybe it would be easier if you can directly reference the memory address of the PLC. Okay, so that's something that I've seen. It's actually enabled by default in Kepware. That's why I discovered that. So what is possible is that I will not have the access right to modify a specific tag. But if my user is authorized to use dynamic tags, instead of typing in the name of the tag, I can just type in directly the address of the memory of the PLC. And if I'm allowed to do dynamic tags, then it will bypass the access control on the tag because I'm not addressing the tag, I'm addressing something else called directly the memory address, okay? So that can be useful in pentest situations.
Like,
okay.
Do you have specific access control on the dynamic tag, or do you have no access control on it?
I can actually show you the way it works. Again, the way it works in Kepware, and I'm saying Kepware because that's the software that I assessed. The client policy is quite, I know it's small. I have no idea how to zoom in from my VM. I can try to reduce. Not too bad. So that's a user group. It's called a YOLO. As you can see, I can define the permission on the IO tags quite precisely. So basically, for each part, I can say read, write, etc. However, dynamic addressing can only be done device by device. Okay, so it's really possible that I'm not allowed to access one tag, but I can bypass this feature by directly referencing the address. There are not millions of addresses in a PLC. Basically, in a Modbus PLC, you will have 65,000 coils. That's a Boolean value, 0 or 1. And you will have 65,000 max registers. So it's 8-bit value. So it's possible to brute force that. And then you can directly read and write to the PLC memory, which is, of course, a bad idea because those solutions are usually meant to collect some data, and you do not want the people that have the right to collect the data, process it, to do some data analysis. You do not want them, most of the time, to be able to write directly to the memory of the PLC. Okay? In terms of architecture, and that's the last slide, what I assessed was something like that. So it was quite secure. You would have a factory with the ICS network, a firewall, the OPC UA gateway, so Kepware, for example, another firewall, or the same, but a real DMZ, no flows going through the DMZ, a corporate network with a first type of SAP software, and then another one, SAP in the cloud. The idea, that's something that you see a lot in manufacturing, is to be able, based on the orders from your client, to be able to communicate with the process and say, okay, we need to produce more of this product, that product, etc. And you also want to get the data out to be able to, let's say, perform some data analytics and try to be more efficient. So the way it worked was that from the cloud, you could exchange data with the ERP server that was on premise. This one was able to connect to the OPC UA gateway, and of course, the OPC UA gateway was able to connect to all of the PLCs. So if there is a misconfiguration here, like dynamic tags that is allowed, that means that to some extent, if I get access to your cloud infrastructure, or maybe SAP, let's say for some reason they are compromised or they are bad guys, they could directly impact the process by moving things or by shutting down a production line, or maybe things are a little bit worse, like loosening the quality of your product, etc. That's harder to detect and to understand. Okay, so what I suggested at the time, I don't think that they did it, but is to have two different OPC UA gateways. This one that you can trust as part of the ICS network that initiates the connection to the DMZ and does a copy in real time of all the data, and then this one can be queried here. And this one cannot access here. So even you can do whatever you want. You can try to write to some tags. This one will not be able to connect. It's this one that just copies all the data to this one, okay? So that's something you can do to prevent those type of misconfigurations. So usually I would say you have to configure your Kepware server correctly. And in addition to that, you have to think about a network architecture that prevents any misconfiguration from having a very large impact. Okay? Yes, question.
The previous slide, it can also be used as a channel, channel to exchange information between, for example, a backdoor in the ICS network and an attacker in the cloud.
Yes, it could be a covered channel. Yes, and actually, yeah, should be quite easy. I think yes, could be quite easy to do that. Yes, but here in this situation, really they just wanted the data out, and what I proved during the security assessment was that it was possible. I'm not saying it was simple, but if you have access to here and here, you could directly impact the production, which it's exactly what they didn't want to happen, okay? So in conclusion, so OPC UA is more and more deployed. So yes, as I mentioned, at the moment it's a lot on it's used as a gateway, but most PLCs or high-end PLCs that you will buy today, they support OPC UA. So OPC UA will probably replace Modbus, which is really good because it provides some security features. However, as I mentioned, it's a standard, but not everything is interoperable. Yes, distribution and renewal of certificate is hard. I think we all know how managing a public key infrastructure is complex. In ICS, as you can imagine, which is an environments that are a lot less mature, it's really complex to deploy certificates. So there's actually a part of OPC UA specification. It's called the GDS, Global Discovery Service, kind of internal PKI. But even if this standard exists, I do not know of any commercial or open source implementation. So at the moment, you are left on your own. So most of the time, what people do would be to produce certificates that are valid for 100 years, because they know that it's complex to replace those certificates. I mean, you cannot, if you have it depends, of course, each ICS environment is different, but if you have something that runs 24/7, you do not want to take the risk that in 5 years, you have to stop the production line just to update the certificates. It's a bit complex. So when it's used, when I've seen it used, it was not using certificates. It was using none as the security mode, of course, as you can imagine. But yes, this is really a very difficult topic for people in ICS, knowing how to manage the PKI. Okay, and I also put some additional resources if you want. So that's a link to the tool I just demonstrated. And maybe you know of Clarity. It's a company that does the type of solution I mentioned. They provide you with the sensors that they install on the industrial control systems and then monitor. They help you with the inventory and they monitor for any abnormal connection. And they have an excellent research team. And so they have great articles on OPC UA if you want to learn more about that. And that will be all. Do you have any question that you didn't ask? Was it clear? Yes?
Is there a valid business use case for dynamic addressing?
Dynamic tags?
Yeah,
yes.
dynamic tags.
It's not for me to say. I mean, I just do cybersecurity. People do something, and I come in and I say, it's good, it's bad, but I'm not here to discuss if it's required or not.
No, in the sense that
it's easier.
When you do a recommendation to a client and you say you need maybe to disable dynamic addressing because
most people don't use it.
Yeah,
that doesn't mean that
when you recommend to clients not to activate it or to disable it, they don't have an answer as to say we need it for thus or thus.
In the few cases when I've seen that, they didn't need to enable dynamic tags. It was enabled by default, which is why it was enabled. So what I did was just I read the fucking manual, and that's about it. And actually, Kepware, they have a good hardening guide. So that's how I discovered about dynamic tags, because they said that you need to disable it. And but it's also an example. I was supposed to do something on paper, take a look at the architecture, do a few interviews, but I wasn't sure. So I asked for my contacts. I said, gave me a copy of the Kepware configuration. I spin up 2 VMs on my laptop. I copied the configuration, and I've been able to do some testing. And that's also an example of where I think that it's not enough to do, cybersecurity by design. It's nice, but at some point you have to test things. It's just not on paper. And a lot of my clients, even the good ones in ICS, that for which all the project, they go to the cybersecurity team, they review the design, but there's not always the test at some point. And this is something that's hard to discover if you do not try to compromise it. Yes?
Are you working with vendors directly?
No. This was for...
Only customers?
Yes. Let me try to think. We discuss from time to time with a French vendor that does a secure and... how is it called? They do a secure implementation of OPC UA. I think that to some extent it's proven mathematically. They are sponsored by the ANC as well. So we have some discussion with the feedback from our clients. This is what is difficult for our clients. So we discuss with this specific vendor. And we also work with a few automation vendors, but not directly on this topic.
Is it possible to do some scan by the data historian the server, just to try the just there?
Yes.
Is it possible to do the same by data historian? The same attack?
Yes, actually, it would not be uncommon that the data historian is actually an OPC UA gateway. So yes, data historian. What is the purpose of a data historian? It gets all the data from everything in the process and store that in I don't know how you call that, but in a time-based database. So the idea is that at any point in time, you can go back and say, okay, the value of these sensors was that, and you can, again, do some analysis on how to improve your process. And so, yes, you could probably do the same with the data historian, but most of the time, those will not be two different machines. It will be the same. Any additional question? Okay. Well, thank you. And if by any chance you attend DEF CON this year, I will have a workshop on OPC UA.
Okay, thank you. I think it's